For many of us in the developed world, life is good. We exist in unprecedented comfort, convenience and security. And from the houses we live in to the cars we drive, methanol helps to keep it all running. Methanol is one of the chemical building blocks supporting our current standard of living, and one of the most important tools we have if we want to maintain this standard into the future. Thousands of years ago, it was methanol that made it possible for the Egyptians to embalm everyone and everything. Yet it wasn't until 1661 that a British physicist named Robert Boyle formally isolated the compound. More than a century and a half later, as the Industrial Revolution pushed global population past 1 billion, a pair of French chemists named Jean-Baptiste Dumas and Eugene Pelliot cracked the elemental code of methanol, opening the door to synthetic production. By 1923, Matthias Peer of BASF had developed a catalyst which could convert synthesis gas to methanol. Within a few months, the first commercial plant was up and running at BASF's Leuna works in Germany. As global population hit 2 billion in 1927, annual global production of synthetic methanol reached 21,000 metric tons per annum, a figure that would more than double by the end of the decade. Thanks in no small part to methanol, the consumer age was on. Through the Depression, the Second World War, and the post-war boom, methanol became a fundamental building block for a number of products, ranging from plastics and automotive antifreeze to building materials. By 1965, race cars were motoring around the Indianapolis Motor Speedway, powered entirely by methanol. 1 year later, in 1966, ICI commissioned the world's first low-pressure methanol plant in Billingham, England. Using a safe, reliable and energy-efficient copper-zinc alumina catalyst, the Billingham plant changed the way methanol was produced. Their work continues to serve as the global standard to this day. Yet despite the advances of the 1960s, methanol rarely crossed international borders for political reasons as much as economic ones. All of that was to change with the OPEC fuel crisis of the 1970s. A number of cash-rich OPEC nations embarked on programs to build methanol plants to commercialize their abundant and cheap natural gas. Once these governments satisfied their relatively modest domestic demand for methanol, they sold and shipped the surplus to energy-hungry economies around the world. As successive fuel crises triggered higher and higher oil prices, scientists and engineers were also hunting for ways to minimize the vehicular exhaust emissions at the root of urban air pollution. The methanol industry recognized and encouraged the burgeoning market for alternative fuels. In the US, California went so far as to run a methanol-based alternative fuel pilot program using M85. In 1990, the US government's Clean Air Act mandated the use of oxygenates, including MTBE, a methanol derivative, and demand for methanol soared. Throughout the 1990s, methanol technology continued to develop. Larger and larger plants were built, each one capable of efficiently producing methanol at previously unheard of volumes. But as the use of MTBE declined, US demand for methanol slipped. Simultaneously, huge growth in the use of natural gas for power generation pushed up natural gas prices in both the US and Western Europe. As we entered into the new millennium, the methanol market underwent a radical transformation as production migrated toward low-cost producers in the Middle East and South America. Over the next decade, low-cost countries erected massive methanol plants, some capable of producing more than 5,000 tons per day. By 2009, we were collectively consuming 42 million metric tons of methanol per year, most of which crisscrossed the globe on tanker ships. Most methanol is used to produce other chemicals. Demand grows in tandem with each country's GDP as the developing world's middle classes continue to expand. On top of this, methanol is moving far beyond its traditional spheres. It is becoming a key ingredient in the production of established petrochemicals, particularly via the methanol to olefins or MTO process. In China, abundant coal reserves have led the government to put methanol at the core of China's long-term alternative fuel strategy. China is now expected to constitute half of the global methanol market by 2015 and is predicted to continue to lead global growth in supply and demand for years to come. Whatever the future holds, one thing is certain: methanol will play a key role. Our industry has to balance this demand with the environmental impact of its production. As an energy enabler, methanol will be at the forefront of the development of alternative fuels such as DME, biodiesel, and low-level gasoline blending. China's M85 and M100 fuel standards mean that methanol also has a substantial future as a direct fuel. Right now, new applications for methanol, such as hydrogen fuel cells, are proliferating. Consumer demand for goods produced using methanol shows no signs of stopping. For methanol producers, improving feedstock flexibility, enhancing plant efficiencies, and increasing the use of renewable energy sources will become ever more important. Reality is inescapable. Global population will exceed 9 billion by 2050, and demand for methanol will continue to grow. For the industry to achieve the twin goals of limiting its contribution to climate change while fostering greater energy security, we must seek more efficient ways of producing methanol. Now and in years to come, as more and more people across the planet seek a standard of living that some of us have enjoyed for generations, innovation in production and the use of methanol is paramount.